Good morning, this is Cody Hendrickson. Today we're looking at Java variable passing and how we can actually handle the idea of what happens to a Java variable as it's used inside methods, what the idea of the scope and its variable or its copy or if it's just a reference. And so let's go take a look at that. The first one we're looking at is primitive as a parameter. And we have to remember that primitives are always a copy. They're cheap, they're basically free. We don't have to worry about this, and so we're going to always see the fact that a primitive is always going to be a copy. Whenever I send a primitive to anything, I'm getting a copy of it. Here's a true, here's a false, here's a pi for you, here's a 7, here's that 1.6 billion. That's all right there. They're free. We're giving them away like it's candy. Okay. The variable value only changes if we assign back into the original variable via return statement via assignment operator. And so it's only going to change if we assign it back into the original variable. And so we have a sample right here. We can take a look at this. We have a void method. So obviously the void method, we're not going to return anything back. It takes a double parameter that we're sending at an instance variable as the what we're sending to it. And as you can see right here, I'm asking for a new number to be typed in. We say that variable and we assign it into value. And then we say display message, here's the parameter, here's the local variable, here's its instance variable. If we take a look at the debug screen right below here, we can see that in fact all of these local variables, they're all primitive values right here. If you take a look at this down here, we can see that parsable returns 3453.0, and notice that there is no ID equals, there's no memory allocation attached to this because it's just a primitive. It's just this, oh, free little number right here for you. My instance variable is set to 66.67. My value, original value, is set to 66.67 again because that's what I'm sending to it right here. And then update gets that new value of 34.53. And so when I pause this right here, it's right before that line on this. As soon as I set update equals value, it'll replace that value of the update with 34.53. But 66.67 is never going to be impacted whatsoever. And so when I call my display message method, it's going to say here's your parameter, and it's going to say the 34.53. Here's the local variable, 34.53, and here's the instance variable, still 66.67, because a primitive is always a copy. Never gets anything referencing it besides that. However, when we have an object subparameter, we have a little bit different structure. When I use a setter or a mutator method, aka dot something that makes a change to that, usually they're void methods, of course, we are always going to change that actual object because we're looking inside and we're changing what's inside that. Basically, if you see the dot operator, change will happen. The assignment operator, however, just makes a new local only change. It's going to be a temporary variable that exists from the squiggle to the closing squiggle. That's the only thing that's going to happen with it. And so if you just a temporary local variable, it's just, oh, here's this local variable. As soon as the closing squiggle hits, because scope is out of range, we're out of that variable, it's gone. So if you see the equal sign, remember it's just temp. Okay? Now, strings are special. Strings, however, because all methods on strings don't affect it because a string is an immutable class in Java, it's a special little thing. When we use the method on string, that it doesn't change the actual value of the string. So string doesn't actually get impacted by that at all. And so we'll take a look at that right here in our example. We have a look at object parameter AP sample. And so we have an AP sample object and AP sample.toString.hashcode. And so hashcode guarantees we can see exactly where this idea is being stored internally with Java. Doesn't make anything we can use for it, but that's okay. And so right there we have that right there. When I use example.setValue, I'm making that internal change. I'm using the dot operator. I'm changing the actual value inside it. And so that state does change. However, on that next line, when I said example equals null, or the next line after that, example equals new AP sample, at that point, I've got a brand new local variable that is defined right here at the top at this spot right here. And so it's a brand new local variable. It's a new thing completely. So example has no relationship whatsoever to the original value. And so I do example.hashcode. I'm going to get a different value completely than individual.hashcode that I have in the line below. And when I do display.displayMessage example.toString, that's going to be my default value from the default constructor right here. And we'll see that when we go through and actually do the live code. Here's the string example. And again, remember that strings are immutable. I have that nice little message right there that the string is immutable. And so word.substring returns a substring. Oh, but it doesn't change anything. It's just right there from half of the length down to the end. Okay, great. That doesn't do anything. Woo, yay. So word equals replace the contents of the local variable only. As soon as I hit that closing squiggle right here, that no longer exists. That local variable is out of the way. Only if I use that return statement to actually assign into something will that string example actually make any change whatsoever. Because again, strings are immutable, so it doesn't work anything with that. So now we look at a structure as a parameter. And our structures we're dealing with are either arrays or lists. Of course, there are many other structures, but we have the idea that we can actually keep it in those basic categories. Now, remember, arrays are hipster. They don't have methods we do anything with inside Java that actually do anything for us, and so we don't have any methods to worry about, but we do, however, have the square bracket access. And so that square bracket access is how we're going to go into it. It's like using the dot operator. And so we have array name subindex equals some value. I actually change the array's value because I'm assigning into the address of that index. And so that gives me an internal reference. It's like using the dot operator or method call on that. However, when I say array name equals new type, of some int or array name equals null, it's a brand new local array. It doesn't ever exist again. As soon as that closing scope hits, it's out of there. Okay. On the other side, however, we have our lists. And so we have mylist.set, mylist.add, mylist.remove, mylist.addAll, Those are mutator methods. They actually affect the list. Yay, the list gets changed. The size gets updated, decreased, or whatever. Makes that happen. No big deal. However, if I do mylist equals new array list of type, then at that point, I have a brand new list because it's a brand new local variable. Because again, I'm using that assignment operator. And if I ever see the assignment operator, new local variable. Boom, there we go. And so here's a sample of that right here. We have our look at structure parameter. We're using an array parameter for this one. And so the parameter is words.length long. And so at that point, it's still the same exact value. So it's however long it is. I'm talking to the fifth position of that at word sub 4 equals asda. At that point, I'm explicitly replacing the contents that were at word sub 4 with that new asda, useless bit of key mash. However, I then say words equals new string array size 3. Oh, okay, brand new local variable, so I can't do that. And so words at size 3, I would no longer be able to access word sub 4 because I've got an index out of bounds exception. Ooh, don't want to see that. And so temporary values don't last, so I diploid message words.length, now words is length 3 because it's now a local variable. It exists only inside the contents of these squigs. But I still have access to word array, my original array, that my data member that belongs to that, and that's of length 5, so I can still access that fifth index inside the array, and I can still modify it internally. So I can make the changes to this, but at that line right there, it's still totally okay. And we'll see that as we actually step through and go for the actual review. And so that's right there. Now this also links to the for each loop because for each is a special case. The enhanced Java loop that we have right here, we have a copy of the value inside that structure. So if we use the assignment operator, it's just like it's a little tiny little method right there in the loop. And so it's a local variable. So if I use the assignment operator, it's totally useless. So if I see the equal sign, useless, don't use it. So Eclipse is going to warn you. It's going to give the yellow line of uselessness. Dr. Java, some other IDs, JGraph, not going to tell you that. So just make sure you do it. Setter and mutator methods, however, they do actually get impacted when using a for each because, again, you're using that dot operator. That little dot operator right there says, oh, go inside and look and make mutator changes. I can access state with a dot. So if I see the dot operator, I can access the state. The internal data is changed. Totally okay. We can great review this with inside the photo lab. The zero bool method that comes by default right there uses the for each loop over the array, then a for each loop over the array inside that pixel object inside that, and uses that to go through that. And again, that's a great one to review because the photo project has so many different ideas of structure and using methods and all that great kind of stuff. It's a great exam review for the AP exam. So take a look at that if you have a chance this weekend. Here we have the for each example. We have showed the for each doesn't change the variable, so we're going to look through the word list and we display the contents. And as you can see right here on the left, we're string word word list. At that point, the word is underlined with yellow, the yellow line of uselessness that Eclipse grants us. And so that I'm not actually doing anything to word. Even though I say word equals random silly phrase and word equals null, none of that actually does anything because word right then at that point, as soon as I use that equal sign, the assignment operator, it's a brand new local variable that ends as soon as I hit this closing squiggle right here. It is not helpful. Same thing if it's not just a string. AP sample, sample, colon, example. Same thing. I get the yellow underline of uselessness, even though I'm clearly saying sample equals, oh, equal sign, I'm assigning the variable. No. It's a local variable. It exists only for the purpose of that squiggles. So as soon as I do that, it's useless, it's gone. So it doesn't actually change anything if I use the assignment operator. However, if I go over here to the other side and I show I can change it with an accessor, for AP sample current colon example, I go and access internal state by using the set value method on my AP sample object called current. And every time I do that, I actually make those changes happen because I'm accessing internal state by using a dot operator. And so again, when we do this, we want to make sure we use the idea that the dot operator goes inside. We can make changes to state. However, the assignment operator on methods or inside loops doesn't make anything on there. Now, a regular for loop, of course, because I have access to the square brackets and arrays are special, I can go ahead and do that. But if I just simply go in and say equals new, boom, it doesn't do anything. So we have to make sure we have that ready to go. So let's go ahead and let's take a look at the actual structure of this in action. So we'll go ahead and go back to Eclipse. Maximize. Thump. And here we have the actual class. We're going to be looking at the scope controller class. So we're looking at this. We can see we have some data members. We have a pop-up, I have a string array, I have double array of real numbers, an array list of string called word list, and an array example of AP samples, an individual AP sample, and a double instance variable. So we can see all those lovely things, giving them some values inside the constructor because that's what constructors do. Let's go look at our AP sample class. Again, as you can see, AP sample is just a really quick sample class that's just used to demonstrate the idea. We have our setter right here of set value, which takes a string parameter, assigns the local variable, takes a string parameter, assigns to the instance variable or the data member this dot value. It assigns that value to it, so I can explicitly assign that in. So I have a default internal state because again I'm using the dot operator, and dot operators allow me to go inside and make changes to that. So it's a nice other way to remember that right there as well. My toString just gives me that value, so I actually see what's happening with that. Again, we have our picture.java that I was just telling you about. That set blue takes a 0 parameter. This is an internal method right there. Boom, has the dot set, so it makes an actual change to that. Go ahead and close that, get it out of the way. So our constructor right here has the fill structures methods. Just a quick way to go through and make sure that all of my structures have some examples in it, just to keep my constructor a little bit smaller right here. And I'm just putting some values into it. As you can see, there's stuff inside every one of my structures right there. Again, we're also showing how to use the other way of doing an array in Java, where I make a new double array and then I have an anonymous array that's assigned inside that right there using the initialization list. So we can see how we can handle using data structures right there with that in Java. Nice little reminder before we take the exam. So we go ahead and look at our actual start method down here, our start method, which is the only public method inside the class. As you can see, we're going through and demonstrating what's going to happen inside this. And so we can look at how loops impact the copy and reference variables. We can go through, we have the for does change, the for each doesn't change, the for each can change if we use our accessors. Again, overly named variable names and method names, but we're using this to actually show exactly what's happening. So let's go ahead and do debug, and we're going to go ahead and hit that in here right this. So we'll go ahead and start at that point, get a breakpoint, go to debug mode, switch into this. Enter scope copy reference demo, and let's look how loops impact copy reference variables. And so we have inside here, we have our this variable. You can see that we have all of our data members right here. We have all that access to this. We're here at line 187, again on our stack trace out of the way. And we can see what the values are for all of this. We're going to go ahead and step into this next one, show the for does change. And so we can see right here, because I'm using a for loop, that I have actually able to change that, because in an array I have the access to use the index of that. So a for loop, I have access to the index, so I can actually talk to that spot in the array. And so as I step over this, I'm going to change the values of my real numbers, all multiplying by -1, because that makes it a quick change. So I'm going to go ahead and hit play pause down at this spot right here, so I can see the changes of this. So we'll hit play pause or resume. It's going to step through and go through this really fast. Look in the real numbers array. As you can see, the values of the array are all there. They have values that all make sense. They're all positive numbers. We go back over to our structure. And we're going to change those array values and look in the real numbers array again. And so now we go back inside, look at this. I look at my real numbers array, and as you can see, every single one of those had a change happen to it. They all were that -1 multiplied all the values, so the original value all changed for all of that. And so I can go through and step over that again. And there's the negative values right there. Boom. We're going to look into the word list now. Computer science is the best. CS for all. So we change all those values inside word list. We saw all of them. We look inside our word list right here, and look, there's CS, computer science is for all, hashtag CS for all. Great. And we're going to use our updating, quote unquote, all those methods. Again, remember, use the \quote to do the escape sequence to make a quote happen inside a string. Just a nice little reminder for that. As you can see right here, our word list right there has all those values that we just saw. So I'm going to step over this one line at a time. Boom, boom, boom. And updating the word list and example array. And so we're going to step over this, and boom, boom, boom. As you can see, word is science. I replace word to be some random silly phrase. Word gets set to null. It disappears out of scope because it's just a local variable right here. Boom, it's gone. Nothing happens to it. And as you can see right here, computer science is the best. That's still the same in every one of those positions. Step over, step over, step over. This is amazing. This is just boring. Okay, so let's go ahead and we're going to skip down to this one and hit that sample equals null line. We'll do play pause until we hit that. Oh, sample. Okay, so for each sample, an example. So let's go ahead and close this, go to example and pull that one up. And there's my samples right there, and we'll go inside that, and as you can see, all those values are set to default. Okay, we'll step over. Some should go to null, right? Because we're going to change it? No, because again, it's using a for each loop, and we don't have any changes, so boom. Look, it just goes to sample. It exists, it goes away, it exists, it goes away. This is useless. And so if we look over the word list again, step over that, and look in the word list, and boom, here are all of our values. Step over again. And computer science is the best. Hashtag CS for all. It's amazing. We had that all working. So now we're going to take a look and see what happens when I step over and go into a for each loop and actually make those changes. So we'll step into that. And here's my samples. And so I can go ahead and I can show samples for that. So let's step over that and show samples. And AP value, they're all default. As you can see, all those values are in there. We're going to step over that. Now we're going to use the magic of using a for each loop. And we're going to grab a random number, assign it in. Again, with a random number, we have to make sure we cast it as an int. And we want to make sure we do the actual math on that to make sure we give it a value. Otherwise, we'd simply math.random, cast it in, is always going to give a 0 because it's between 0 and 1. So nice little reminder again for the exam. So stepping over that, we get that math random. Oh, look, there's random 23. I'm going to now set current set values. Let's go look at current. It's an AP sample. Its value is default. I step over that next line, and look what happens. Set value return. No, it's a void method, but I take a look at example. I go look at individual 0, and look, it now has 23. I affected the state because, again, inside that for each, I'm using the dot operator, and when I'm in the dot operator, I can affect state. That's always the easiest way to remember that. Okay, and I'm going to go ahead and we'll go to the next step over this. We'll go to right here and resume. Wait until we get to the show samples, and we'll now go over that inside code. Step over that line, and 23, 34, 12, 12. Hey, works! We changed all those values. They're no longer saying default. Great stuff. Okay. So now we're going to step into the next one. Step over that line. And we're now going to look at our structures or parameters. We'll go ahead and look at the word array so we can see that explicitly happen. So we'll step into that. Look at the word array. Step into the method. And so here we have words.length and words as entry. So words is a 5 array. There are 5 entries in this array right here. And I'm going to use that word sub 4 equals as. So I'm going to make that change right here and make it happen. So I step over this, and in this array is going to be replaced now with asda. So parameter 5 entries in length, that's great. Step over. And as you can see right here, I made that change, that yellow highlight. Sub 4 is now asda. I took out the 5 entries in length. That line, the entries in length part has been taken out of there. It's been replaced with asda because I'm using the square bracket access. And so with an array, square bracket access means I'm actually changing it. I'm looking inside it because arrays are hipster and they don't have any methods, but square brackets means I can go inside and make changes to it. However, right here, line 174, that next line, when I say words equals new string array, let's take a look at this. Words right here, ID 142. And I go over here on this and I look at my word array. Oh, ID is 142. It's the same exact memory location. But right here, when I hit step over this line, watch what happens to the ID. Oh my gosh. It's new. It's a new string of size 3. That's ID is 229. But look at word array. It's still 42. It's still 5. And look, my contents of word array are still there. Oh, good. I didn't destroy my data. This local variable now is only for this. And so I can have this happen. So it's a brand new string array. I can assign temporary values don't last. Step, step, step. Okay. And display messages. It's now going to be only 3 in length. Step over. Let's watch that happen. It's only 3 in length. Wow. That's amazing. But look what happens right here. Word array sub 4. I can still say what's inside it, and in word array sub 4, I can still grab what's there and add a modifier because, again, it's a square bracket access. It's just like using a dot in a regular object in Java. And so I can still affect my word array because word array still has 5 entries in it. Words, only 3 now, so I can't access that spot. If this was actually working with words, if I was talking the same thing, I would have destroyed my data. I'd have a local variable now. It's only a variable for my class member. It's only this big, but I'm not. It's just a local variable at this point. So I'm not going to throw an index out of bounds exception. Yay! But as the data can be modified. So that value is now inside that spot. I didn't break my code. Yay. Okay, good to know. Take a deep breath. All right. So we're going to display the message again, verify we did not change that, and look. Array is 5 entries in length. Yay, I didn't actually destroy my data. Good to know. Okay, so let's demonstrate with primitives. We're going to step over that one really fast. And step over. Step over. So instance variable 66.67. Here's a guess. Step over that. Okay, we're good. And instance variable, we're going to do, here's the guess again. We're going to use that method call on that. Step over that line. Look at this line right here. Write in a new number. Okay. Use not a number. Can't type that in. Okay, we go in. Here's the new parameter, 1345.60. Here's the local variable right here. Here's the instance variable, 66.67. We've explicitly not made that change, so let's go ahead and take a look at the code for that. So we go over here inside our method. And here's that line called right here, parse double. I grab the number from the user. I have the variable. Here's the local variable's instance variable, and I can hover over this right here. Here's my instance variable. I've got that all right there. I'm on that line waiting for this to happen. Display message is actually over, so I actually didn't catch that, so I didn't show it to you. Oops, that's okay. We'll be fine. Okay, say okay. The method's done. We're going to step over this next line again. Step over. Here's guess again, instance variable. We're going to look at primitive with return, so we'll go ahead and step over that. See, 66.67. Never heard it. Okay, we're going to go look at primitive pair with return statement. Step into that, and here's my parameter. Okay, here's my value again. Notice that I don't have anything happening on this. I don't have an ID because there's no memory allocation. It's just a brand new fresh copy because it's a number. It's cheap. Okay, so I step over that. Value is 99. Okay, and I step over this. Here's the parameter. Step over. Now my parameter is 106.66. That's great. That's wonderful. I'm going to return that value now. Step over. I return that value. Step over that line, and because when I return that value I didn't do anything with it, right here in line 202, oh, okay, step over, great. I go take a look at this, I go look at my instance variable, look, it's still 66.67. It's just sitting there, because yeah, it's tiny. Okay, step over, and we're going to go ahead, and here's the guess yet again, 66.7 point, still the same, good to know. Hey, I even have it in there in my name, sweet. And we'll go ahead and do this again now with guess 2, so I'll step over this again. And here's the parameter, and now guess 2, and guess. Hey, clearly separate values. We're good to go. Okay, so guess 2 right here, it exists at 106.66. It's still right here because I haven't left scope, so it's just going to sit there and hang out. Nothing's going to happen to it though. Step over that. Okay, line 207, we're going to go into an object parameter, so we'll step over with that. Okay. And we're going to use that object parameter, that individual. So let's go look at individual right here. It's a value of special. So we have a special AP sample example right here. We're going to step into this method so we can see what happens. And here's my object parameter. I have my AP example sample. Okay, it's right here. ID is 37. I look at my this so I can look at my current object. And here's individual, and its ID is 37. Look, numbers match. Oh, great. Okay. And so now I'm going to look at my toString right here. Step over that. Pop this up. And my value is special. Okay, good. It works. That's what it's supposed to do. I'm going to look at my next one right here, step over and look at the hash code, and we can see that these are the exact same values. And so as you can see, my parameters, these are the exact same. My parameter hash and the data member hash, they're okay. But now I updated my hash, so I've got, oh, my updated parameter hash, because I made that change to my code, so let's go take a look at that right here. So I use that internal state change, so I take a look at this, I look at my this variable right here. I look at my individual, and I look at my value, and my internal state change stays, it no longer stays the same. And AP sample, my value is default. My blank one right here, that new AP sample of example, nothing's inside it. Okay. I say okay again. And here's my AP sample. My internal state has stayed. Oh, I changed my internal state. Sweet. Okay, so I'm going to go back into Eclipse, go back over here. We're going to take a look at this with a string parameter. We're going to see that we're not going to make any changes whatsoever because strings don't make changes. So we step over that again. So we're on line 211. Yep, we're on line 211. Sweet. Demonstrate with a string parameter. And there's a string parameter right there. We step over. We're now go ahead and get response. What word should we use? So we'll step over that as well. And so we'll use computer science rocks, exclamation point. Go back over here. And so my answer right here, computer science rocks, I've got that value. And we'll look at that string parameter now with that answer. So I'm going to step into this line. And here's my word. Oh, word is now computer science rocks. Okay, sweet. If I go back here to line 213, I have answers computer science rocks. So you can see that's where it was right there. We're going to go back to line 161, so that's where we are now. And so we're going to have our display message. Remember that strings are immutable because we never changed the actual string itself. So I'll step over that line, give a nice little pop-up. Strings are immutable. We want to remember that. Okay. We're going to go word.substring, word.length, and watch what happens to word. Okay. Step over. Nothing. That's amazing because I didn't actually change word. Both those methods don't impact word whatsoever. Okay. And word equals replace the contents. Now this, however, this one does change. And word is replace the contents of local variable only. So word now has that value. So I've returned word, so I'm going to send word back, step over. And I come back in here with this, and the answer is answer. Okay, so look at string with return, step over that. And the answer is computer science rocks, because I didn't actually assign back into answer. Answer is right here. I never assigned back into it, not until I do this next line, 215. So I'm going to go ahead and I'm going to hit resume, play pause, and until I get back into this, computer science rocks, strong's immutable, local variable only, because I replaced it now because I went back and actually assigned into it. And now I go back into this, I've terminated my scope because I've now exited my program. So again, just a quick little example of what we're doing here. We have our methods right here. We have the fact that a for does change because we always have access to the actual address of the variable. So we can show for does change because in a for loop we have access to this right here. We have the index. We can always change values of an array or a list with a for loop because we have access to the index. The index is what makes us able to make those changes. Okay? In a for each loop, however, a for each doesn't get to change the variable because we don't have access to it internally. It's just a local copy that exists right here. We can see that inside Eclipse. It gives us the yellow line of uselessness right here, saying that nothing happens to it. But if I go and actually use a for each loop with a mutator method, like this case, set value, I actually do change the structure. And notice also no yellow line of uselessness on current because I'm changing current with that set value method. Okay, fantastic. We look at my primitive parameters. Primitives are always copies, so it doesn't really matter what's going to happen. So this instance variable is still itself. Any changes I make right here are just copies that exist all in the stack. And they go away as soon as I hit the squiggle because they're stack copies and they go away. Primitive with return, same thing. Object parameters, object again, if I go inside and right here, no change. But if I use a set value, I'm using the mutator method, I can change that. But as soon as I use the assignment operator says, oh, brand new variable. Okay, something new, don't have to worry about that. Same thing with structure. Right here, square brackets means I have a brand new variable. I'm just accessing this internal structure, so I can make changes to that. Same with the .set, .add, anything like that in a list. But when I use this assignment operator right here, equals new string, boom, brand new structure. Don't have to worry about anything else because the original value right here is still 5 and I don't have to change anything, it's still there. So quick little review, have a great day, and we'll see you on the exam. Have a nice time.